Test the series for convergence or divergence. To test the series for convergence or divergence, notice that a sub n is written as -1 to the power n minus 1 over square root of n. When we have n equals 1, the top part is -1 to the power 0, and that is positive 1. Then after that it's gonna change to negative, then after that to positive, and so on. So the idea is to think about the alternating series test. So let's get started. So we have the following. This right here is equal to the summation from n equals 1 to infinity of a sub n. This is our a sub n. We're going to break it down to two parts so we could identify what is b sub n. So that is equal to summation n equals 1 to infinity -1 to the power n minus 1 times 1 over square root of n. And this part right here is b sub n. Now clearly b sub n, which is 1 over square root of n, and n is an index that takes values from 1 to infinity, is greater than 0, which is positive. So all the terms of b sub n as a sequence, they're all positive. We have two conditions to test. Number one, that b sub n as a sequence is decreasing. Which is true. We know that 1 over square root of n plus 1 is less than 1 over square root of n for all n. The first denominator is greater than the second denominator, so the fraction is smaller. Next, we need to talk about the limit of b sub n as n approaches infinity, which is clearly is equal to 0, because the limit of b sub n, and that is 1 over square root of n, as n approaches infinity, the denominator gets to infinity, so the fraction gets to 0 as a limit. So the conditions are valid. Therefore, we could say that the series that was given to us, which is summation n equals 1 to infinity of -1 to the power n minus 1 over square root of n, converges. By the alternating series test. That should do it. To go over this kind of quick as an overview, we have the following. This is the alternating series test that shows once you identify b sub n to be greater than 0, clearly that b sub n that we looked at as 1 over square root of n. That is greater than 0, which is what we have. And also we showed that it's decreasing and the limit is equal to 0. So the series that was given to us is convergent. And that should do it.